Let's briefly remind ourselves about one of the variables we use to determine the optimal sample size for a study, the confidence level. This, along with margin of error or acceptable error, are two of the variables that we get to set to our own specification in order to determine the optimal sample size. Typically, marketing researchers pick the standard confidence level of 95% when conducting sample size calculations. This isn't a magical designation, though. This practice of setting it at 95% is usually based on just adherence to historical practice, the flawed "that's the way it's always been done" argument, marketers not really knowing any better, thinking that there is a precise or special reason why you set it that way. Or third, at the 95% confidence level, it is a point where we approach an approximate point where the benefit-cost ratio of additional information gathering does begin to decline rapidly. That is, all else equal, if we want to get a little more confident in our answers, it can require a lot more data collection once we go beyond 95%. We'll illustrate that with some examples in our tutorials and practice. Now, when we use the word confidence, the correct statistical interpretation here is if we hypothetically sampled an infinity number of times and repeated our analysis, X%, the confidence level, of the time, we would find results within the range of answers. Of course, keep in mind that confidence level and margin of error are intertwined concepts. I'll be emphasizing this point several times. You can't really talk about confidence level without also speaking about your margin of error. Both need to be spoken about at the same time. Now, in human language, we express confidence in percentage terms, 80% confidence, 90% confident, and so on. Of course, in everyday common language, we probably are aware that humans as a whole tend to have a massive overconfidence bias. So when we casually communicate to one another how confident we are in something, we tend to drastically overestimate our level of confidence. When we are using confidence in human language here in marketing research studies, we try to mean those percentages quite literally. When we are 90% confident, we are literally exactly 90% confident. Still, in statistical language, we never really use confidence level, right? We typically use things like z-values to actually express our confidence level when we plug it into math equations. Thus, we need to be able to translate from human speak, the way we understand the numbers, to statistic speak, the way the math equation wants those values. You should already be familiar with using a z-table or an online calculator to translate a confidence percentage to a z-value and back again. That's an intro stat thing. To remind you, you should memorize that a z-value of 1.96 is associated with a two-sided 95% confidence interval. This translation is so commonly used in marketing research, it's something that should be available at the top of your mind, not something you have to look up. 90% confidence and 99% confidence are also very common, but there's no need to memorize those. Now let's talk about acceptable error, or the margin of error that we set when determining an optimal sample size. First, let's talk about it in the context of a dichotomous variable, where we're trying to calculate the sample size for a percentage variable. Acceptable error is also set by the marketer ahead of time, just like confidence level. You get to specify what you want the acceptable margin of error to be, and the required sample size will be arrived at based on that requirement. Further, keep in mind that confidence level and acceptable error are intertwined. Both are simultaneously required to determine the accuracy of any study. Now, for percentage variables, a percentage margin of error of 3, 4, and 5 percentage points is quite common in practice. If you look here from a YouGov study in 2015 and 2018 that measured the awareness that US adults had of Lyft as a company, you'll notice there's a drastic shift in how many people were aware of this ride-sharing company. Digging a little deeper into the original data, they actually only had a margin of error of 1 percentage point for these estimates based on a 95% confidence level. So they deviated from the common practice of a 3, 4, or 5%. They were even more precise. Now, when dealing with dichotomous variables or percentage calculations, we always express the margin of error with percentage points. This makes it easy for us to deal with in the sense that the metric is always the same. For continuous variables, or where we're trying to calculate the optimal sample size for an average, it's a bit more challenging to determine the proper level of acceptable error. This is because understanding what the margin of error means is entirely determined by the specific scale that we're using for the continuous variable. So, for example, if someone just said the margin of error was plus or minus 1.5 points, now without any other context, if we're not paying close attention, that might sound like a very small margin of error, but it could also actually be very huge. Imagine if a Likert scale was the scale that was used associated with that margin of error of 1.5 points. So here we have a 5-point Likert scale, like we would have agree and disagree labeling on the points here. Now, if we had a margin of error of 1.5 points to an average calculation of 3.5, our margin of error would tell us that our estimate of the average is somewhere between 2, meaning disagree, and 5, meaning strongly agree. That's totally useless. Our margin of error basically covers the entire range of the scale. And as a warning, this is a common trap for new marketing researchers. They often see small numbers or larger numbers associated with margin of error when calculating an average, and they leap to the conclusion that it's either a big or small margin of error in practice. And that's not the case. You must understand the scale that was used to understand whether or not the margin of error is too substantial or very precise for purposes of our study. Finally, I need to emphasize that confidence intervals and margin of error are in fact distinct concepts, but they always work together to make sense of an uncertain world. So consider the following question. If someone asked you, what is the range of games from low to high that you think the Golden State Warriors are likely to win in the next NBA season? Now, your answer probably varies quite widely depending on how much knowledge you have about the NBA. In some cases, you might have to go look up and see just how many games there even are in a regular, should emphasize regular, NBA season. But to answer this question appropriately, keep in mind that we always have to articulate both our confidence in our answer as well as our margin of error, or our range of possibilities. So for example, here's someone who has both low confidence in their answer and also a very high margin of error. They say there's a 60% chance that the Golden State Warriors will win between 40 and 80 games next year. So 60% I'm subjectively interpreting that to be a relatively low level of confidence, and a margin of error plus minus 20 games, so 40 to 80, is a rather high margin of error for a regular season that's 82. Now here we have an individual who has a high level of confidence in their estimate, but they also still have a high margin of error. This person thinks there's a 95% chance the Warriors will win between 30 and 81 games next year. They're very confident, but of course that range of their estimates, in other words, a high margin of error, is quite wide. Here we have someone who has a really low level of confidence. They think there's only a 20% chance that the Warriors will win between 65 and 68 games next year. However, that low margin of error, notice the small difference between 65 and 68, implies that they have a relatively precise margin of error there. They're just not very confident in that precise estimate. Finally, we have an example of someone who has a reasonably high level of confidence, and they also have a reasonably, I'm using those words subjectively of course, low margin of error. This person says there's a 90% chance that the Warriors will win between 60 and 70 games next year. Notice how in all of these examples, to make sense of someone's estimate, confidence interval and margin of error had to exist simultaneously. Now keep in mind, we're giving everyone here the benefit of the doubt that their actual articulations of confidence and margin of error are based on some rigorous methodology. We're assuming these weren't just probabilistic chances they made off at the top of their heads. That's really not a confidence interval at all.